The reason you can't wash away oils or fat with just plain water is because it doesn't dissolve in it. But how do you make fats dissolve in water? Well, the answer is simple. Soap. But how does it work and how can you in theory make yourself one at home? So now I will go over the history of soap making and the chemistry behind it. Then I will do the theory on how I will make my own soap, and then I'm gonna show you the process. So here are the I guess the points you can skip to if you want to skip any of the topics, which I don't think you should because I really think the history and chemistry behind it are really interesting. So back then the people used to make soap with three main ingredients. 1, ash from wood or whatever. 2, some animal or vegetable fat, and 3, water. Now I'm gonna go over each of the components and what they do in the reaction. Okay, so give me the table of elements real quickly, okay? So what ash contains mostly is some calcium compound. For example, calcium carbonate, mostly, okay? So it's basically some calcium compound. And the things that you really want when making soap with ash, potassium and sodium hydroxides. So basically these two, which are in the first element group, I guess, okay? Now, when these bond with a hydroxide ion or whatever, then they make a really strong base. Like sodium hydroxide, which is the one I'll be using, is really, really strong. Now the thing is how the people back then used to separate the hydroxides, the first element group hydroxides, with the calcium carbonates is pretty simple. You see, the calcium compounds weren't very soluble in water. So what they did was they just dissolved the ash in water, and whatever didn't dissolve was the useless calcium carbonate. So yeah, they then mix this with fat and some water. Okay, basically the water doesn't really participate in the reaction. It's just to mediate it in a way. So it doesn't like really react that vigorously, and so it can disperse betterly. Betterly? Okay, that doesn't make any sense. Better. Okay, it can disperse better. Okay, that's enough about the base for now. Let's get to the fats. Okay, so basically the animal or vegetable fats are basically only made up of triglycerides, okay? Triglycerides are just basically 3 glyceride molecules bonded with each other, okay? So 3 glycerides, okay? And now they are each composed of 1 glycerol part, 1 ester bond between 2 oxygens, and then a fatty acid chain, okay? Now what happens is when the strong base reacts with that is, it breaks the ester bond and makes the glycerol part polar. And what that means is the fatty acid chain is still non-polar, but now the glycerol side, it is polar. So what that means is that the glycerol side becomes hydrophilic, I guess, and that just translated just means water-loving, and the other side, the fatty acid side, that becomes then hydrophobic, so afraid of water. You know the word phobia, right? Yeah, that's kind of the same thing. Now, what happens then is you have this, okay, the one end is attracted to water, the one end is attracted to oil, okay? And now basically what happens then is, if you have a oil somewhere in water, or not in water, whatever, okay? When you get soap on that oil, what happens is the fatty acid chains, they all stick inside of the oil. So it's kind of like, you can imagine it like a sphere, and then there's kind of a ring, no, not a ring, like a little surface or whatever, like a little coating of those triglycerides. Well, there aren't really triglycerides anymore, of them around it, where the glycerols are sticking outside in the water and the fatty acid chains are sticking inside of the oil. Yeah, and basically this sphere then can get transported through water because it's kind of soluble. I guess the thing itself isn't soluble, but the outer side is soluble, so it can get easily transported. So, hello people who skipped ahead. Now, there is one tiny bit of chemistry you still have to understand because it's very important for the soap making. So here it is, the theory of making the soap itself. Bring me the table of elements real quickly too. You see the first element group here, okay? They all can form hydroxide, okay? There's lithium hydroxide, there's sodium hydroxide, potassium hydroxide, cesium hydroxide, whatever, okay? Yes, there also is hydrogen hydroxide, which is just water. Hydrogen hydroxide, water, is not going to be included in the rule I'm going to say now, because hydrogen acts very differently from the other alkali metals, okay? The alkali metals are basically the first group elements just without the hydrogen, okay? So, yeah. So, the trend I was noticing here is, the further down you go, the more liquid the soaps get, okay? So lithium hydroxide, this is the hardest soap you can possibly make. It's used as lubrication in heavy machines. Then sodium hydroxide, this is ideal for like hard soap. And then potassium hydroxide is what you're gonna wanna get for liquid soaps. And then as you go down, like, why the hell would you do that? Let me tell you one thing. Cesium, rubidium, and francium are expensive as f***. Okay, so francium, only a few 100,000 atoms, I think, of it have been produced. And that's like not a lot. And it is just an interesting fact. It is estimated there on the whole Earth, there's just a few grams of francium because it's just so incredibly radioactive. So I'm gonna be using sodium hydroxide because I want to make hard soap. So now here is the oil. I did get some pine needles because I wanted it to smell good, but I didn't want to buy some etheric oils for some pretty high price. So now I heated this to about 4 of 15 degrees of power, I guess. Now you can feel the warmth of it. This has been for in there about 2 hours. I think I'm gonna put it out soon. Before I do that, I'm gonna have to make the lye solution. Yeah, so I was actually too lazy to go get my scale, so I'm just gonna do like about 2 teaspoons. Not teaspoons, I mean tablespoons, okay? Go in there. Okay, like that's about what I need, right? Wait. Yeah, I can imagine that being around 18 grams. No, I can't. Wait, I need a little bit more. Like this. Okay, this has to be enough. Yeah, turns out I may have overestimated the amount of oil I used. Yeah, that's not too much. I hope and figure it'll still work though. Oh, for a soap itself, this is a pretty good height. Now, I guess, now the products have kind of cooled out. The sodium hydroxide is still warm from mixing with the water. By the way, if you're doing this at home, be careful, because 1, the sodium hydroxide is very dangerous, like, I'm not even kidding. And 2, when you dissolve sodium hydroxide in water, it releases a lot of energy when it ionizes. Basically, in monkey terms, sodium hydroxide, water, hot. Okay? Got it? Now I'm gonna pour that in, I guess. Is there any correct way to do this? I have the feeling there is, but... Okay, is anything special happening yet? No? Come on. Still this sodium hydroxide, I don't know why, but it's really sticking on there. But I am getting it off, kind of. Okay, I finally got it out. Now it's time to blend. I then blended it for about 4 minutes in total until the liquid was kind of viscous, I guess. This is now, I let it stand for 30 minutes. This is it after 30 minutes. Well, it's still liquid, but it's way more viscous. Now I'm gonna let this stand until tomorrow, then put it in the oven for 2 to 3 degrees at 70 Celsius, which is this many freedom units. Yeah. Okay guys, so I dried it in the oven now, and something isn't quite ideal. I don't know if you can see it, but it's like there's a barrier at the top where I guess it's just a little barrier of dry soap, and underneath that is the wet soap that has to dry out. Now what do I do? Wait, look at this. Until now it is just a theory, but look at that. See, that's really green, like liquidy green, okay? But if you look at it like that, yeah, that's pretty dry. I have this, this toothpick here. Now I'm gonna test if it's actually liquid under there. Come on, focus camera. Thanks. So let's see now. Fuck crap. Okay, what do I do? I don't want to just poke a lot of holes in there, because then my soap would then be pokey. That word doesn't exist. Okay. But anyway, by the way, these things may look like holes, but they really aren't. They're just bubbles. Speaking of bubbles, look at that. Look at how many bubbles there are in there. How did I not think that bubbles were gonna be a problem? Okay, there it is. I'll have to destroy it now. Oh, this hurts so much. I hate this. Okay, I mean, the result is mediocre. It's not as good as it was before, obviously. But I guess, okay, I mean, it's fine, but... Oh, it smells so extremely good. So yeah, it's a few days later, about 3 or 4 days, and the soap, what I thought was gonna happen is the soap is gonna get dry, just, and then it's gonna contract a little because the water is getting out of it, and that's not really what is happening. But what is weird though is, wait, this. You see that? Okay, it looks dry here, right? But then you spin it, and why is it so wet on that side? I don't know. But now I'm gonna cut the soap out with a toothpick, and then I think I'm gonna put it in the oven. Okay, to be honest, I'm really regretting not making a silicone, like, crucible. You don't call that a crucible, right, when making soap. Anyway, this with the glass, it's really annoying. I'm doing it like this. I'm just stabbing it continuously, which is working better than all the other methods I've tried, but it's not working well at all. So yeah, about 10 minutes later, it didn't take me too long, I'm done. So yeah, oh shit, I maybe should clean that out. So yeah, now it's cleaned out, and the thing is, when I like push against it, it can like kind of rotate. Do you see that? Yes. Oh yes, it's falling out. Crap, I need some more paper to hold it. Okay, so here's all the material that I kind of pulled out with the thingy. That is not a toothpick. I know it's a little bit large, but when I used the toothpick, it broke. Well, that shouldn't be very surprising. And now let's get the soap onto this paper. Okay, that worked just fine. Okay, interesting. Now, do I put it in the oven? Now I kind of cut off all the sides a few days later, because it kind of looked ugly, to be honest. But this isn't quite drying out properly, so I think I'll put it in the oven. I'll risk it.
I actually forgot to say in the videos that I dried the soap, and I did so for about 50 degrees Celsius for 2 hours. By the way, I'm kind of sick right now, that's what you might be hearing.
So, okay, it's been 1 week, and this is just not getting any drier. I mean, it's hard, kind of. It's kind of soft. I can put a dent in it with my fingernail, but it's definitely a lot better. And it's still, the surface is still kind of wet. I don't think it's just because of the moisture. I think it's also because of the glycerin, and because I super fatted it, which is basically when you add more oil than the sodium hydroxide needed. So then it becomes kind of more fatty, which is better for skin. So I did that on purpose, because I really didn't want to get too much sodium hydroxide on myself, because I have done that already with pure sodium hydroxide, and it stung really, really much. So now, screw it, I guess. I will just go take a shower and wash my whole body with this. Also, I'm just starting to realize, why is this green? The ingredients I put in there were yellow. Look, the coconut fat, white, okay? Sodium hydroxide, white. Olive oil, yellow. This green, why? You might think, oh, the pine needles were green, but yeah, I mean, that doesn't discolor too much. The whole product, it's probably just a chemical reaction. The soaps that are produced may be green for whatever reason. Damn, that felt actually really good. Oh yeah, I can only recommend that. I think that's actually better than most of soaps I used, and I do not use them cheap soaps. Yeah, I will definitely do that again. Next time I will probably buy some essential oils, I guess with some pine essential oils and something like that, because I really like the foresty scent. But you can really try this at home. It's not too hard and pretty simple to make. You just have to wait a little. But I think it's definitely worth making.